Let's have a look at problem 6. The regular hexagon ABCDEF has area 1 and center O. What is the area of the quadrilateral ACEO? So what they're asking is, what is the area of this orange, arrow-looking shape? Okay, well, I don't know about you, but this seems like you might not really know where to start, right? It's one of those type of problems. But with these geometry problems, what I always like to do is I want to make sure that I can extract as much information out of the problem statement as I can. That's step number 1. We make sure that we understand what all the words mean. And then second, from what is given, are there any other things that you can derive from that? That if that is true, then this must be true as well, which is not written, right? Let's see if we can do that here. So the first thing that says is that it's a regular hexagon. What does that mean? A regular hexagon means that all of the sides of the hexagon are exactly the same length. Okay, and it has area 1, all right, and center O. Well, and of course the quadrilateral is just a shape that has 4 different sides. In this case, this arrow-looking shape, ACEO. So based on that, I'm actually thinking that this is a figure that you can draw on, right? And don't be afraid to just start drawing stuff on the figure, if that makes sense. So for me, I have an inclination to, because we're dealing with the area, start splitting up this shape into smaller pieces. Let's see if that gets us anywhere. So let's look at if we were to connect F and O together. If we were to connect F and O together, we were to create this kind of diamond shape looking shape on the left side. Let me actually go ahead and connect all of the corners with the center O. Let's see. This is one as well. We now have a nice looking triangle. Here we have another triangle. What is this? What is the similar thing between this triangle and this triangle? Well, if you can see, this is a regular hexagon, right? Which must mean that they have to have the same area. It's really just the same triangle, just flipped. Okay, that's cool. Let's continue splitting it up like that. And I think you might even be seeing how you can solve this way, because if we were to split the last one, we now have, that was a horrible, not a straight line at all, but we'll live with it, is 6 different pieces that we have in a hexagon. So that must mean then that all of these triangles are exactly the same, which means that they have the same area as well. Okay, well, the shape that we're looking for is this one right here. And so what can I say about this shape right here? Because this part of it, it's like, of course, this area, this side is the same length as this side. Same length as this side, obviously, right? Because these two are parallel and exactly the same. And then this one also is the same length. So that must mean that if we were to split this up into triangles through this diagonal, that the area of this is the same as the area of this. Aha, okay, well, the area of this is exactly what we're after, or half of what we're after, right? The second part is obviously going to be exactly the same, just mirrored like this. So how do we find out the area of this thing right here? Okay, well, we know that the entire shape has an area of 1, which means that if we were to draw it out like this, plus this, plus this, plus this, plus this, plus this is 1. Yeah? And so that means that if you were to add these up, 2 and 2, you get this shape. So there are 6 of these, right? 1, 2, 3, 4, 5, 6 of these. So the area of any one of these triangles must be, so this one has to have an area of 1 over 6, which means that this also has to have an area of 1 over 6. What does that get us? Well, 1 over 6 plus 1 over 6, that's going to be 2 over 6, which is the same as 1 over 3. Now, that gives you the area of this one. And you know that half of this arrow is just a diagonal split of this thing, which is just half of that. So what is half of 1/3? Well, that's going to be 1/6 again, right? And what we're after is this one. And then the other one over here, the other part, which is just the same area again. So the final answer would be 2 times 1 over 6, which would be 2 over 6, which would be 1 over 3, 1/3. And so A has to be correct. Okay, I really love this problem because it seems pretty scary at first, but all we had to do was to really understand what's a regular hexagon. Well, that means that we can split it up as well, right? Because if we're dealing with the areas, the smaller triangles must have the same areas. And as soon as we did that, that was kind of the key insight to this one, because then you could see, well, now I can kind of continue splitting it up and then find, 2 together and then diagonal, and then you have it. So that's kind of the key with some of these geometry problems. You just gotta start with the most obvious, which you think you know everything, but if you start really writing it down and then using the figure to start, drawing stuff on the figure and writing down stuff, then it starts making sense.